The big new idea that we're going to embrace here in this section is that of intercept form of a quadratic function. Before we get there, I want to remind ourselves of standard form and vertex form characteristics of quadratic functions. So first of all, dealing with standard form, this example that you see right here is an example of an equation that is a quadratic function. And a big thing that makes something quadratic is that the highest exponent on the input variable is a 2 right there. And anytime we have a quadratic function, its graph will be that of a parabola. So just in general, whenever you have something that's in standard form, you will have that your output variable, your y, is equal to some number times x squared plus a number times x plus a number. That's what we consider to be standard form. So we will eventually prove and verify why this is the case, but the axis of symmetry for the parabola, if it's in standard form, is always at negative b over 2a. So in this particular case of this parabola, since your b value is negative 12 and your a value is negative 2, then negative b over 2a will be negative of negative 12 over 2 times negative 2. So you get a positive 12 on top and negative 4 on bottom, which will equal negative 3. So therefore, our axis of symmetry for this parabola is x equals negative 3. What that tells us about the graph then is that negative 3 equals x, this line right here will cut the parabola directly in half, which then means the tip of the parabola, its vertex, has to be on that axis of symmetry. So then we'll know that the vertex has negative 3 for its x-coordinate, and then we could plug it into the equation to find the corresponding y-coordinate. So if we did f of negative 3, we could do negative 2 times negative 3 squared minus 12 times negative 3 minus 10. So you'll get negative 2 times positive 9, because that's negative 3 squared. That'll be plus 36, because it's a negative times a negative, and then minus 10. So basically, you just got to figure out negative 18 plus 36 minus 10. It'll end up giving you an answer of positive 8. So therefore, negative 3, 8, that point right there will be where the vertex is located for this particular parabola. Because it's stretched by a factor of 2 right there, then instead of 1, 4, 9, 16, 25, everything's going to be multiplied by 2. So 2, 8, 18, 32, 50, right? That would double all the perfect squares. So when I go over 1, we'll go down 2, and then when I go over 2, we'll go down 8, and then when I go over 3, we'll go down 18, that sort of a thing, right? And you can copy and mirror that over to the other side, just like that. All right, and so that gives us a nice sketch of the parabola. We also know that it's upside down because that 2 there was negative, so it's a downward-facing parabola overall. We do have some x-intercepts, I guess, that are nice whole numbers. You can see that they're located at negative 5, 0. Make sure you express them as coordinates, not just numbers, negative 5, 0 and negative 1, 0. And then in terms for the y-intercept right there, since we know that a y-intercept always has a 0 for x, you could plug 0 into the equation, which then if you did f of 0, you're going to get negative 2 times 0 squared minus 12 times 0 minus 10, which will just equal negative 10. And that does correspond to the fact that, yeah, it does actually cross through the negative 10 right there. So those are the big things that we need to deal with standard form. I guess with the vertex, I didn't write the 8 right there. So yeah, let me highlight in green, I guess, those big things that we found, those big characteristics of the graph of that. All right, and then just some reminders of graphing quadratics that are in vertex form. So this right here is in vertex form. Recall that vertex form is always a times x minus h squared plus k. So like the h and the k are really important because the h, it will tell you the horizontal shift of the graph, and then the k will tell you the vertical shift of the graph, the vertical translations, and then that a just stretches or compresses the graph overall. So in this particular graph right here, it's going to be a quadratic function because x is squared, but inside the grouping symbols, since it's minus 6, it's actually going to shift the graph right 6 units, and then minus 4 right there is going to shift the graph down 4 units. So the vertex of the graph, if it goes right 6 and down 4 from the origin, the vertex is going to be located right there. And then if I just graph the parabola from here, because it's got that 1/2 that compresses the graph, then rather than 1, 4, 9, 16, 25, 36, the perfect squares, it's instead going to go half of that. So it's going to go like 0.5, 2, 4.5, 8, 12.5, 18, because that's half of those numbers, right? So if we go from the vertex and we go over 1, it's only going to go up half. And then if I go over 2, it's only going to go up 2. If I go over 3, it's only going to go up 4.5. If I go over 4, it's only going to go up 8. And if I go over 5, it's only going to go up 12 and a half. So somewhere like there and there, right? Okay, so that gives you that parabola a little bit wider than normal because of that compression factor of 1/2. All right, and then finding some of the characteristics of this. So clearly the axis of symmetry is going to go right through that positive 6 right there. So x equals 6 gives you the axis of symmetry. The vertex is at positive 6 because it went right 6, and then negative 4 because it went down 4. So 6, negative 4 is the vertex. For the y-intercept, we know that is going to be 0 for x, and then we can plug 0 into the equation. So if we plugged 0 for x into the equation, we'd have 0 minus 6 squared, which would be 36 that we'd have to take half of and minus 4. So it'd be 18 minus 4, which is 14 equals y. So therefore, the y-intercept should be at 0, 14, and that should be logical because if you look at the graph, eventually it'll hit a little bit more of a positive number, and so 14 does seem to make sense right there. And then finally, in terms of x-intercepts, you can see that because it has a point right there and a point right there, right above 3 and 9, that then it's got to be crossing through like 8 point something and 3 point something. So they're decimal numbers, so we're just not going to worry about those x-intercepts quite yet. We'll eventually learn very soon, actually, how to find those exact x-intercept coordinates. But we're just not quite there yet.